moment. So I'm just going to show you something. So how are we going to find the inverse of the function? Okay, so what we're going to do over there, we have the different steps to find the inverse of the function. So in the very first step, like we can replace f of x with y, and then we're going to just exchange or interchange or swap the x and y. And after that, in the third step, we need to make y as the subject of the formula, and then we're going to find the value of y. And then at the end of that, we need to write the f of inverse x in the place of y. Okay? So these are the 4 steps while finding the inverse of any function. Yeah. So you can just have a look. The example is given. Suppose when we're talking about f of x, so f of x is 3x minus 5. So in the very first step, what we need to do? We need to write f of x as y. We did that. Okay. And after that, we need to swap the x and y. Like swapping mean like we're gonna just replace x as y and y as x. Okay. And after that, you can just have a look. X is equal to 3y minus 5. Now, after swapping them, so we need to make the y as a subject of the formula to find the value of y. Okay. So you can just have a look after this step. What we did, we just shift the 5 to the other side. So it becomes x plus 5 equals to 3y, because we want to find the value of y, because so we're going to divide 3 on both sides, so 3 over there and 3 on this side. So from there we this 3 will be cancelled out, so we can say that y is equal to x plus 5 divided by 3. And at the end of that, in the step 4, we need to replace y as f of inverse x, and this is our inverse. Okay, do you understand this? Perfect. So now we're gonna just try the question. So we can start from this part, like the question, it is already given, so you need to find h inverse x. Let me just move it down. Okay, so this is a question, just move down. We need to find h inverse x. Sorry about that. Okay, carry on. Okay, so this is the first step. We just replace hx as y, and in the second step, what we need to do? No. We need to swap the x and y. Okay. Now you can make the y as subject of the formula. Perfect. And at the end of that, very good. Yeah, you did it. Okay, now we're gonna do some exam questions. Yeah, okay, you can carry on. Okay, let's try this question. Okay. Mm-hmm. Yeah, you can try this in two ways. Like, first of all, you can find f of gx, and then you can after that you can just plug in like x as one. This is a one way, and another way you can find g of one first, like which you solve this the part A. Okay, so you can just find g of one first, and the answer which you will get, you can just plug in that in the function f. Mm-hmm. Okay, carry on. So it will be 2 over 4, and that will be 1 half. Yeah. Okay, now you can plug in this in function f. Yeah, that's right. Perfect. That's the right answer. Okay, so let's try to solve the part B. Mm-hmm. Okay. G. No, 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 no. I don't think so. That is look like that. So you need to find gf of x first. Mm-hmm. Like in function g, you can just plug in f of x, the whole function. Yeah, in the place of x. So there will be 3x plus 4 plus 3. Yeah, like that. Okay, perfect. So now g f of x have a value that is 6. So in the place of g f of x, we can plug in 6 like that. Now this is an equation, so you can solve it in order to find the value of x from there. Mhm. Okay, you can simplify it. Very good. That's the right answer. So these are the exam style questions. Okay, so I hope you understand this. Now we're gonna do some more question that is related to the inverse. Let's move down and try to solve this. Like range of x mean the element which we will get after plugging in, they will all of them are real numbers. So over there, like he said, like state range of f. Like we need to first of all, you need to just have a look. Like in the function, there is something is given. Like x belongs to R, x greater than or equal to -1. So this is a domain is given. Okay, and now we need to find the range of f function. Like range mean we need to find like when we plug in these numbers in the function, like which are given over there. He said x greater than or equal to -1. So they are basically -1, 0, 1, 2, 3. Like we can put any number, okay, from there. So when we plug in these numbers, when we just input this number in the function, so which type of number we will get as an output, that will be our range. Okay, yeah. Yeah, to check that like which type of number we're gonna get, and we can just make like general statement like this will be the range of the function, like these type of number are in the like range of the function. You can just choose like when we just plug in -1 in it, so can you just tell me what we will get when we plug in -1 in the function? When we plug in -1 in the function, so we will get 0. Okay. And when we plug in 0 in the function, what we will get? Mm-hmm. Okay, x is equal to -1, then we can say that f of -1 is equal to 0, and f of 0 is equal to 1. Okay, so after plugging in 0, so when we plug in 1 in it, so what we will get? Okay, so we can say that f of 1 is equal to 4. So you can just have a look these numbers which are given over there, so they are increasing, right? Like 1, 2, 3, 4, 5, 6, 7, all of them are positive, right? Okay, so we're gonna make the statement on the basis of the least number. So because the domain, this is the domain have a restriction that every x must be greater than or equal to -1. Okay, it may be greater than like -1, 0, 1, 2, 3, 4, and equal to -1. So we have started from -1. So on so we have a least number that is a -1, right? Okay, on least number we got the value that is 0. So as when we input a least number, so we just get the least number as an output that is a 0. So from there we can make a general statement because all of the values, all of the terms in the function, they're positive. So ultimately we will get all the positive numbers, right? So on the basis of this, we can say that like f of x greater than or equal to 0, that will be our range of the function. Or in other words, we can also write as y greater than or equal to 0. That is also represent the range of the function. So you must need to remember x represent the domain of the function, y represent the range of the function. Y or f of x, the both one are represent the range of the function. Okay. Do you understand this? Like how we gonna get that the range of the function? Okay, perfect, fine. So now you can try the part B. So sketch the graph f of x and f of inverse x on the same diagram. So are you able to do this? Mm-hmm. 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 We already got that. Like you can just have a look when we put like 0, 1, 4, like negative 1, 0, 1, and like that. So you can find more coordinates, so you will get the general idea, and then on the basis of that, you can draw the graph. Okay. So the function is quadratic, so its graph will be in the curve form, right? Okay. Okay. And now we're gonna draw the inverse of the function. Okay, so let me tell you about that. You can just have a look from the function. We get the idea like its domain is x greater than negative 1 because it is gonna start from there, right? And it is going on like that, right? Okay. And we also get the idea like its range is greater than 0, greater than or equal to 0, right? Okay, so when we are going to draw the inverse of the function, so that like because we already know the like graph of the original function, so you must need to remember that the domain of the original function will become the range of the inverse function, and the range of the original function will become like domain of the inverse function. Okay, suppose you can just have a look like when we're talking about f of x. Like we have f of x function, and that will be like x squared plus 2x. I'm writing over there, and plus 1, right? So we got the domain that is x belongs to R and x greater than or equal to negative 1, right? This is the domain of the function, right? Okay, and we got the range of the function that will be, we can say that y also belongs to R, and we can say that y greater than or equal to 0, right? Okay, okay. So we didn't got the inverse of the function. Now I'm just supposing that like we have a inverse of the function. So now this is a domain. So let me write over there. This is a domain and this is the range. So now we're gonna inverse, like take, we can say that exchange them. So we can say that x greater than or equal to 0, that becomes domain, and we can say that y greater than or equal to negative 1, that will be the range. Okay. Yeah. So I'm saying, like, when we are drawing any function, or when we're talking about domain and range, this was the original function, right? Okay, its domain is given in the question, so I just wrote the domain of the question over there. That is x belongs to R, x greater than or equal to -1, and we find by using the process, we find the range, that is y belongs to R, and we can say that y greater than or equal to 0, right? Okay, so this is a rule, like while finding the domain and range of the inverse function, we don't need to do any extra step. We gonna convert the domain and range of the original function into the domain and range of the inverse function. Okay, and this is a rule in the functions, like the domain of the original function becomes the range of the inverse function. Okay, and the range of the original function becomes the domain of the inverse function. Do you understand this? So I did the same thing. You can just have a look. I didn't find the inverse of the function. I'm just talking about the domain and range. So the domain was x greater than or equal to -1. That was domain. So I make that as a range of the inverse function, and the range of the original function y greater than or equal to 0. So I just make that range as a domain of inverse function. That is x greater than or equal to 0. Okay. Okay, so now let me tell you on the graph. So when we're talking about the range is like -1, so we can say that it will be -1 over there. Let me make it. So -1 over there, and it will goes like in that way. Let me draw over there, like in that way, right? Okay, so you must need to remember that, like while drawing the inverse function on the graph, so inverse is the reflection of the original function. Okay, so how it is a reflection? So you can just have a look. If I just draw a straight line, so you can just have a look. They must be like equal but in opposite interaction. Okay, yeah, this is the thing about the graph, like how we're gonna draw the inverse of the function and all these things. I hope you understand this, right? So you can try one more question and then we can end the lesson. Okay. Okay, let me just move the question over there. So this is about the natural log. So you can try. Okay, so I'm just moving you down. Yeah, here we go. Okay, let's try it. Yeah, this is an ln. Ln means natural log. You know about the logarithm? Oh, okay, no problem. So you can just try this question like as we are doing. No problem. Just plug in the values as we were doing. When we do the regular lessons, so I will explain you about the natural logarithm and logarithm and all these type. So right now you can treat as this is like variable function. Okay. Mhm. So you're trying to find f of 1, right? We don't need to write any extra f right now, so we are just trying to find f of 1, so we can write like that. Okay. Okay, so let me tell you about this. So the natural log 1, that will be equal to 0. You need to keep in mind natural log 1 equal to 0. If you have a calculator, so you can check it, or otherwise we can do it later. Well, I will explain it to you. Okay, so the value, so you need to consider that like when we just solve natural log 1, so its value will be 0. Okay, so this is f of 1, so we can say that f of 1 is equal to 2. Okay, what we need to do after that? Yeah, okay, perfect. Very good. You can simplify it, so we can say that 2 plus and 3. Yeah, that will be our answer, final answer. Okay, we did that. Like we plugged in the 1 in the function. You can just have a look in the very first step, right? We plugged in 1 in the function, and after that we got f of 1, so that is 2, so we plug in 2 in the function, and that's it, right? Okay, perfect. So the next thing is that like how we gonna find f of inverse x. So suppose, let me just give you an example about that. Suppose we have a square root. How we gonna remove the square root? Can you tell me? So it means square and square root, they are like opposite to each other. If we want to cancel square, we're gonna take the square root. If we want to cancel square root, so we're gonna take the square, right? Okay, perfect. So over there, like the opposite of natural log is an exponential function. Okay, so when we are going to remove the natural log from any expression, so we can take exponential function on both sides. Okay, the exponential function, like exponential function gonna be represented by e. When we gonna remove natural log from any function, so we're gonna take the opposite of that, that is an exponential function, as I just gave you an example about the like square root and square. Okay, so let's see, we are going to find the like expression for f of inverse x. Let me just move this. Okay, so you can just have a look while finding the inverse of the function. So in the very first step, we need to replace f of x as y, right? Okay, so it becomes 2 plus ln 2x minus 1. In the next one, so we need to swap the x and y. So it becomes like x is equal to 2 plus ln into 2y minus 1, right? Okay, perfect. So after that, because we want to find the value of y is in the ln function. So what we're gonna do, we can just remove this 2. So it becomes like x minus 2, that will be equals to ln into 2y minus 1. Okay, do you understand this step? Perfect. Now, because there is an ln over there, so I told you like if we want to remove ln, that is a natural log. If we want to remove natural log, so we need to apply the exponential function on both sides. Okay. Okay. So what the exponential function do? So when we apply e on both sides, so it becomes e to the power of x minus 2 and on this side it becomes e to the power of ln into 2y minus 1. Okay, do you understand this step? No. I'm not using any calculator over there. So I'm saying, like, if we want to remove the natural log like ln, so we need to take the, like, we can say that we can apply the exponential function on both sides in order to get rid of ln, so that we can just free the y and then we're gonna find the expression for y, right? Okay, so after this step, ln and y, like ln and e, they will be cancel out each other as square and square root. So similar to that, so it becomes e to the power of x minus 2 equals to 2y minus 1. Okay, is that step understandable? Yeah, definitely. Okay, so after that, because we want to find the value of y in order to get the exponential function, the inverse function, so it becomes e to the power of x minus 2 and plus 1 equals to 2y, or in other words, we can say that like y will be equals to e to the power of x minus 2 plus 1 divided by 2, and at the end of that, we can write it as f of inverse x equals to e to the power of x minus 2 plus 1 divided by 2. This will be our final answer for the inverse of the function. I hope you understand this. Okay, so let's sum up the whole lesson. We discussed the function, like what is a function, right? And after that, we discussed like the composite function, like how we're gonna combine the function, right? And after that, we did like how we're gonna find the inverse of the function, right? Okay, perfect. So now you can just give a like feedback or review about the whole lesson, so that I will get to know like whether you understand the whole idea, the whole concept which we have just discussed in our lesson. Like how was that? Okay, perfect. And what do you think? Like my way of talking and like the behavior of understanding observer. Okay, so in future you will continue with me. Inshallah. Okay, so let's just tell if you have an interesting experience in master. Okay, I hope to see you soon. And still, after laughing, if something, so you can ask me to the WhatsApp chat. I will be happy to answer it. So, inshallah, we will continue soon. Okay, see you soon. Have a nice day. Bye bye.